Did you know the moon is not part of Mars? This week we're going to be talking about the moon and moonquakes, and here's a great diagram of the moon. I found out something really interesting, that the moon experiences quakes, and being really interested in geology, especially tectonics, as I've mentioned in previous videos, I had to look this up. The moon is experiencing quakes, and there are a number of planets that have some kind of tectonic action happening on them, or volcanism, or something like that. Geologic processes that are active, and generally we think of the moon as just this rock up there in the sky. Well, that's not exactly true. Before we get into moonquakes and explaining moonquakes, how old is the moon? Well, we know that the Earth is 4.54 billion years old, and the moon, which is pretty old as well, is 4.51 billion years old. And why is that important? Because the moon is actually younger than our planet. The most common theory about the formation of the moon is that another body named Theia came and collided with the Earth as we knew it at that time, and it ejected material which became the moon. And we don't really have any proof of that, but like nothing that's like, oh hey, this thing here, that's definitely Theia. But we do have proof that that's what happened through the fact that testing the rocks of the moon, there is a significant amount of material that is similar to our Earth. And when we do other chemical and scientific analyses, we find that the materials and the ratio of the elements that make up the moon are very, very consistent with what makes up the Earth. So that theory is called the giant impact theory, or the collision theory. There are other theories about the formation of the moon, that we captured a passing object and it became part of our satellites. And that is known as the capture theory. They all have names that are pretty self-explanatory. And the last and final one is called the co-formation theory. The co-formation theory has pretty much been ruled out and is not the most favored of them. It means that the Earth and the moon formed at the same time. And so they formed at the same time, and because the moon was smaller, it started orbiting the Earth because it got caught in the gravity of this much bigger body that was forming. And so that is pretty much how we got the moon. So, other facts about the moon. The moon actually does have an atmosphere. It is very, very thin. You would not survive on the moon. That's about what would happen, and then you'd die. And you wouldn't like implode or anything, but you would not be able to breathe. Your body would slowly shut down. And that is something for a different discussion. How do you die in space when no one can hear you scream? Well, you're in a vacuum, but not on the moon, because there's actually an atmosphere. So the moon is our friend. We write poetry to the moon. We sing to the moon. We've got all these songs about it. When the moon hits your eye like a big pizza pie, that's amore. We've attributed love and all kinds of interesting things. If you're a lunatic, it's because the moon is having some kind of an effect on you that makes your brain unstable. And we have all of these things, and yet it's only recently coming out, even though we've had data since we went to the moon, that the moon is experiencing quakes. So normally we do think of the moon as just this static thing in the sky that changes with its position around our planet and the amount of light that is reflected. But it's not as static as you think. It is not a completely dead ball of rock. There is some stuff going on within the core of the moon. So let's talk about that. What's causing quakes on the moon? There are actually 4 kinds of quakes on the moon. There are deep quakes, which are actually within the body of the moon. And those are attributed to the pull of the Earth on the moon. There are meteor impact vibrations, which that's pretty self-explanatory. Something hits the moon and it vibrates, kind of like ringing a bell. And then there are thermal quakes. Thermal quakes are pretty similar to what we have down here. When the moon gets hot because the sun is reflecting off of it, it expands and can cause quakes as the rocks expand. Because suddenly the mass is parting and pushing against other masses, and it only very slightly changes, but that is enough to cause a quake. Now, when the moon goes into its 2-week dark cycle, suddenly all of that thermal energy it's been collecting from the sun is slowly moving away. And it is letting off that energy, which means that the moon is contracting now. And when you have contraction, you also get quakes. So here on Earth, we have quakes, and there are some places that are really famous for earthquakes, like California. And that's because we have a bit of a different system. The core of the Earth is molten, and what we are on the crusts, are these plates, and the plates kind of swim around our planet, not very fast. You wouldn't notice it unless you're in one of these quakes. And there are lots of different kinds of quakes here, and similar mechanisms happen on the moon with these thermal quakes. So you get subduction, where pieces of Earth move under each other. And you get slip faults, where 2 pieces of the moon are moving against each other. The 4th kind of quake is called a shallow quake, which only happens on the surface. And those are the 4 kinds of quakes that happen on the moon. How do we know about the quakes? Well, we send equipment up. So what happened was, with the Apollo program, we sent Richter scales because we wanted to know if the moon was really just this static ball of rock. We wanted to know when things were hitting it, if that had an effect on it, and we wanted to know if anything was happening within it as well. So we brought up Richter scales, and Richter is the measurement that is used here in the United States to measure the magnitude of a quake. The Richter scale is old. It was developed in 1935 by Charles Richter. And what they do is they take the location of the quake and they use 3 different areas and the length of time it takes to feel the vibrations, and that is how you get a Richter reading. Briefly, very, very abbreviated style of what your earthquake did. In a more concrete way, let me just explain it like this. 1 and 2 Richter earthquakes are pretty much never actually felt by us here. 2 and 3, all the way up to 3.9 Richter, can sometimes move objects along in your house, like books on the shelf or a glass on the table, something, but not like enough to cause damage, or probably not even to make it fall off. 4 to 4.9 Richter scale earthquakes, and quakes in general, are enough to knock things off the shelf or knock shelves off walls, kind of like cats. I hate this shit. Level 5 to 5.9 Richter scales, you're really going to be feeling it because it can actually do damage to the structure around you. And then everything after that is really bad. Everything after 6 point is pretty destructive. So you probably remember the World Series quake. The World Series quake in 1989 was really catastrophically bad. It was a 6.9 Richter scale magnitude earthquake, and it collapsed highways and did significant damage to structures and unfortunately killed quite a number of people. And that was just in California. On the moon, we don't get quakes that are quite that bad. They usually range from the 2-point to the 5-point in range, and the worst are usually impact quakes. We have all this data because I'm just going to read this. Apollo 11, 12, 14, 15, 16 brought seismometers to the moon with them, and the devices were working from 1969 to 1977. So we have a very good range of data collection. Seismometers are not the only way that you can observe quake information. There's visual data from photos that we've taken of the moon that shows scarp faces. A scarp is a sudden drop off. It's basically the quick geologic formation of a hill or a cliff. So there is a sharp drop in the elevation, or a sharp drop in the elevation, something like that. And we'll throw a couple pictures up of scarps on the moon, and that shows evidence of the contracting and the shrinking of the moon. So the other interesting thing about the moon is some of the quakes are actually because the moon is shrinking slowly over time. As it spins and gravity has its effect on it, you know, when you roll a ball of clay, that's basically what's happening to the moon. And as it dries and outgasses, it gets smaller and smaller. It will never shrink completely to like a marble size or anything like that. But at some point, the amount of outgassing and the amount of shrinkage that's possible within the structure of the moon will eventually stop. And we're talking about billions of years. It's not going to happen in our lifetime. In the geologic record, you know, it's a couple of weeks. But in our lifetime speaking, it's not going to happen. And who knows, if we keep going the way we are and thinking that the moon's part of Mars and that we can just, you know, find another planet or whatever, humans might not get to see it ever. But that's neither here nor there, and Kane might cut that out, or he might leave it in because he thinks it's funny. So if you're wondering about the scarps, so they've found 3,500 of these scarps on the face of the moon. It's pretty cool. Lots and lots of photos. In geology, one of the things they taught us was basically taking these very high resolution maps, and then you have this like magnifying glass, and you just sit there and you look at these pictures, sometimes like as big as this notebook here, and you're just like this with a little magnifying glass looking at geologic structures, because you can figure out what has occurred by looking at the structures. And scarps really only happen when there has been a sudden massive geologic movement. They can happen during earthquakes, failure events, which are things like landslides and things like flooding and other massive sudden events that just cut a straight line across. Another really cool thing about knowing this about the moon is that we have an analog. We've observed things here on our planet, on Earth, and we can take that knowledge and those ideas and apply them to science on other bodies within our solar system or beyond. I mean, we have discovered exoplanets. We have not actually gotten close enough to see what they're like, but maybe someday. Maybe someday. And other interesting bodies in our solar system are Europa. Europa has a form of tectonic action going on that's all ice-based, and it's really cool. Mars actually does have tectonics occurring and quakes. There are Mars quakes. And no, the moon is not part of Mars. That just hurts my brain and my heart so much. But when you're out there in the night and you're looking to the sky and you're reading poetry to your lover, and she says, "Do not compare me to the inconstant moon," and you're like, what? It's Shakespeare. It's from Romeo and Juliet. Just remember that somewhere up there, the moon is shrinking very, very slowly. And you're a witness to it. Isn't that weird? If you're a fan of Penny Arcade, that says Tycho Crater on it. Tycho. I think I'm funny. I think I'm funny. So let's all go get weird now. And I have lost my page because I was showing you Tycho Crater. Meow meow.